Hello, I'm glad you are here. Result from my past 9-semester algebra-based physics class shows that students who successfully complete the assigned algebra worksheet by first week of the class pass the class by C or better letter grade. My name is Ramesh Dungana. I teach physics and astronomy at the University of Colorado, Denver. In this video, you will learn an efficient way of doing algebra by remembering a couple of rules. You will learn to solve a single or system of equations in terms of variable. You will also learn to interpret an equation in terms of real physical quantities like mass, velocity, and distance. Yes, physics is a rocket science. It is not easy peasy subject, but it is not that difficult as well once you learn some necessary tools. Algebra is one such important tool for doing physics. In physics, most equations are solved in terms of variables first, rather than plugging in numbers. First chance we get. Look at one simple but very important equation in physics. The Newton's second law of motion. It is written as F is equal to m times a. Did you notice there is no x or y or numbers? In basic algebra class, an equation may look like this. When you first learn algebra, most equations may have had x, y, and z and some numbers. We use physics equations to solve problems or derive other equations. More importantly, we use them to describe what is going on around us in the nature. We don't read this law as F is equal to m times a, just like I did before. Rather, we read this equation as net force is equal to mass times acceleration. Notice this equation relates force, mass, and acceleration and tells us how changing one changes the other. Physics equations are telling us something. Our task is to understand the language and use it to solve problems, describe the concepts, and much more. Therefore, we don't rush to plug the numbers for the variables in an equation. We solve them in terms of variables to describe what is happening in the nature. Look at this slide and check your basic algebraic skill first to see how proficient you are in solving an equation in terms of variables. Solve the given equation and choose one that closely matches your solution. After that, you can see the correct choice. But until you produce answer, please pause this video. The correct answer is C. If your answer was either A or B, then it means that you forgot that the solution of M should not have M in it. There is M in the solution. There is M in the solution. But this question is about solving for M. If your choice was D, it means you made sign mistake when you moved them from one side to another side of the equation. Now let's actually learn how to do or solve this kind of problems correctly. So let's first start with the basic. An equation has one and only one equal sign. It means two sides are balanced. So this is one side we call left-hand side, and this is another side we call them right-hand side, and they are equal. And left-hand side and right-hand side are balanced. To keep it balanced, any mathematical operation must be done on both sides. For example, to solve this equation for x, we first subtract 3 from both sides. Thus, the result can be written as Now take a moment and look at equation at the top and the equation at the bottom, this one, new equation. So the first equation versus this equation. What do you see? I see 3 on the left-hand side moved to the right-hand side. So it was on the left-hand side and it moved to the right-hand side. But it changed the sign. So it was positive. Now it is negative. In other words, the operation is now opposite. Addition operation on one side becomes subtraction operation on the other side. They were balanced before and they are balanced now. Before, 2x plus 3 was balancing 11. Now 2x is balancing 11 minus 3. So equal sign still there. Equation is still valid, but we have written this equation slightly differently. So this you have already learned in your algebra class, wherever you learned that. But what you want to keep in mind is that rather than going through this process of writing negative 3 here, and then drawing a line here, and then canceling 3 from this side, and then writing like this, what we do is we simply remember that this positive sign becomes a negative sign when the term moves to the other side. To summarize, simply remember that the positive sign from one side changes to negative sign to the other side and vice versa. So if it was negative, then this would have been positive here. When a term in an equation switches aside. Once you recall it, you complete the job neatly in one step. No more mess. Now we need to move the number from left to right to solve this equation for x. 2 is multiplying the x. When we move it to the right side, it will do the opposite operation again. That means it will divide the other side. Since it is multiplying everything, since 2 is multiplying everything on this side, which is simply x, when it moves to the other side, it's going to divide both of these, not just one term. So that's the solution in terms of number. Yes, you can simplify this and write a number. In physics, we do not want to simplify, let's say, wherever we get the first chance. Rather, what we do is we just keep them. So, for example, if these were variables, not numbers, you couldn't write 11 minus 3 is equal to 8. For example, this could be a minus b or m minus a, something like that. Right? So we leave them as it is. So what's the second thing you want to remember? Multiplication in one side becomes division to the other side and vice versa. So we do not want to write something like this. So no more this kind of extra step. Simply go from here to here in one step, and from here to here another step, and you have solution. So this is a real physics equation. Go ahead, pause this video and solve for acceleration, or A. So solve for this. So did you start? Did you pause the video? Learning physics is like learning to ride a bike. You need to practice it. It is my turn now. The A is in the second term of the right-hand side of the equation. Solving for it means moving everything else on the other side. Therefore, we move first term, which does not have the A, to the other side. So no sign means positive sign. So you want to read something like this. And when it moved to this side, becomes negative. Okay, so we got rid of one term from this side. Now let's get rid of this S and 2 so that we have simply A that we are trying to solve for. So since S and 2 were multiplying A, when they move to the other side, they are dividing this whole thing. The thing we remember that multiplication becomes division. Now it's your turn. Here is some real equation you encounter while doing physics. Go ahead and practice algebra by solving them. Algebra is a necessary tool to do physics. If you learn to solve using the method we discussed here, math part of physics will be a lot easier. So the last question on the last slide had two equations. It is a system of two equations. The given solution assumes that you know M1, M2, Z, but you don't know T, and of course you also don't know A, so that's why you are solving for A. To solve such problem, you need to make use of all equations in the system, but you still solve one equation at a time. Which equation you start with depends on the given equations and what you are trying to solve for. In this question, you are asked to solve for A. The quantity T does not appear in the final answer. Therefore, you want to eliminate it. After you determine the quantity you want to eliminate, choose one equation from the given set of equations that is easiest to solve for. In this example, first equation is easier to solve for T. This is easier to solve for T. Therefore, start from there. Move the second term on the left side to the right. It changes the sign. So this is first term, and move it to the right side, and it changes the sign. So negative becomes positive. We isolated T. After that, we need to substitute it in another equation. Okay, so we substitute this over there to eliminate T. And this equation becomes this. So here there was T, now there is this term. So notice I put parentheses because the T has negative sign in front of it in the second equation. We want A, and only unknown in this equation is A. We are almost there. After eliminating T, the second equation becomes this, where this one here takes place of this T over here. So now open this parenthesis to take care of the negative sign. It changes the negative term to the positive term and vice versa. So for example, here there is positive sign, so it becomes negative, and this positive sign also becomes negative. So the equation looks like this. Both of these are negative. And recall, we are solving this equation for A. And since there are A in two terms in this equation, we collect these two terms in same side and move other terms to the other side, changing their sign. This one has to go this side and becomes positive. This one has to come this side because there is A in here. Similarly, this one doesn't have A in it. That means it's going to go to this side here. Okay. So after this movement, this looks like this. Now, this one has a negative sign, this one has a negative sign, this has negative sign, only this one has a positive sign. Often, when there is negative sign in the first term here, what I like to do is, I like to convert those negative signs to positive. So to do that, I can multiply both sides of the equation, means each term by a negative sign, and which changes the sign of all the terms. So that way, this negative becomes positive here, this becomes positive, this becomes positive, but this being already positive, it becomes now negative. Okay, so that's why the result looks like this. So in this case, again, we are trying to solve for A, and A is here, A is here. That means we need to factor A from this side so that we can isolate it and move the M1 and M2s to the other side. So that's how I'm doing here. So A was factored. Since A is here, I can factor it out. If I were to open the parentheses, this A gonna go there, A gonna go there, so I haven't changed the balance of this equation. On the right hand side, I haven't done anything. There was positive sign here, I simply did not write it. Positive sign, remember, we don't have to write it. So after moving this parenthesis term that's multiplying A to the other side, we get this, and that is the solution for A. So now we can tell how A changes when we change either mass number 1, mass number 2, or Z. So basically this problem is done, but since this is a system of equation and T is also not known, after finding A, you can now use this A over there and find T as well. So go ahead and solve the equation for T by substituting the A. Please pause this video here, try it yourself first, and then watch video. Remember, there are more than one way of simplifying equations. If your method is a bit different than mine, that is fine. However, your final answer should be same. And the final answer I get is this. So did you get the same one? If you haven't paused the video and haven't tried it, please do so. And then you can play this video to see the solution. So after substituting, we get this equation here. So I'm color coding the substitution I made for A. Recall that we are solving for T now, and it is first term on the left side of the equation. So I need to move the negative M1G term to the right side. It becomes positive M1G after switching the side. The first term also has m1 already factored, and there is m1 in the second term. And first term also has g over there, g over there. So we can factor g out and write something like this. After factoring this g out, it becomes this. And now we can factor whole m1g. What's left is this much. And that's what I'm simply copying here. Since m1g is gone, what's left? Not 0, it's 1. m1g times 1 is m1g. So that's why 1. Now we need to simplify the right-hand side by adding two terms. This term, which is fraction, and this term, which is just a number. So let's recall how we add such fractions in arithmetic. So for example, when we are adding 5 to this fraction 3 over 4, what do? We need to make same denominator so that we can add the numerators. So over here there is denominator 1, here there is 4. So we want to make denominator over here also 4. So how do we do it? So what we do is we multiply and divide this number by this denominator, 4 and 4. So that way we have same denominator. So this is basically 5 times 4, which is 20 over 4, and this is 3 over 4. Let's do the same thing here. What is denominator here? m2 plus m1. So we multiply and divide this 1 by m2 plus m1. And that's what we did. So multiplying by 1 doesn't make any difference, so I don't have to write 1 over there. So now we need to add this one and that one. And since they have same denominator, adding them is easier. Again, going back to arithmetic, when we have same denominator, we can simply add the numerator and write that denominator. So we are doing same thing here. Okay, so this denominator, I'm copying it and I'm just adding this and that and not writing parentheses anymore. So that's why we are getting this negative sign m1, positive m2, and positive m1. So this negative m1 and this positive m1, we can add them together to make it 0, or in another word, we can cancel them. Once we cancel them, we are left with m2. m2 means 2 times m2. So that is basically the solution for t. We can write it slightly differently, like this. So now let's take a look at the example of use of equation as a variable. In physics, energy of motion is called kinetic energy. An equation for the kinetic energy is given by half mv square, where k represents kinetic energy. So kinetic energy depends on mass of the object and velocity of the object. So now let's say if you are asked this question, how does k changes when v doubles? When v becomes 2 times v. Whatever v was, if it was 5, now it becomes 10. If it was 2, it becomes 4. So that's what doubles means, and we don't need to know a specific number to answer this question. Okay, so what we need to remember is v here now becomes 2 times v. So take a moment and make a choice. Now, let's see how do we work on this. So here, only thing that we are changing is v. So in this equation, what we want to do is assume mass is not changing, means mass is constant. And 1, 2, these numbers are also constant. That means we can rewrite this equation like this. Everything else is constant and times this v square. V goes to 2v, v square goes to 2 times v squared, so that means it becomes 4v squared. So we recover v squared, but there is now one more term, that is 4. So we get kinetic energy, new kinetic energy, 4 times the old kinetic energy. So that's how we make use of equation with variable to answer a question like this. Another one, this equation gives you gravitational force between two masses m separated by a distance d. Okay, big mass, small mass, just like a gravitational pull between Earth, U, let's say, and separation distance between U and Earth is d. We measure distance from the center, okay? And this g is a constant, a number, okay? So now it says, how does F change when d increases or decreases? So you can write this equation as F is some constant divided by d square. When d becomes smaller, F gonna be larger, but by what fraction? So for that, again, you do the same thing. Let's say d goes to 2 times d. Then what's gonna happen to d square? Or 4d square. So you pick up a 4. Everything else is same. You pick up a factor of 4. See, d square is still d square, but you pick up a factor of 4 in denominator. So that means force becomes quarter when distance doubles. It's not half. Okay, so that's how equations with variables are used in physics to predict what happens. Have a great time doing algebra. If you are enrolled in my class, I'll see you in class.